Hey guys, I appreciate the fact that you guys are working really hard on getting your assignments completed. And I've had a couple of students reach out to me and say that there was some confusion about 8 through 18 in the packet. So I wanted to just record like a refinement explanation of what I expect on these problems. Hopefully, this will reduce some of your stress and anxiety about it. So, let me flip over to the beginning of the worksheet. So, this is in your packet. Problem 8, it starts with worksheet 3 LOL diagrams. And in the original instructions, I shared a video with you that was working all of the problems, and I told you to work 8 through 18. Um, when I went back and looked at them, I recognized that. So sorry, guys. Um, I recognize that several of them are not, in fact, closed systems. So I have edited the number of problems that you are responsible for completing. So if you look here, we're going to do number 8. You do not have to do 9 or 10 because it puts something outside of the system, and that is beyond the scope of this classroom, this course. If you look on 11 through whatever number that is, 16. I want you to do number 11, number 12, and number 14. These others you are not responsible for doing because, again, those have things that are happening outside of the system. And then on the last set, the last two, you're just going to do number 17, and you do not have to worry about doing number 18. So I think eliminating some of those problems will minimize some of the confusion that you were having. But I also want to make sure I take the time to go through some examples with you just to make sure that you understand what the expectation is for the problem. I think the video does a good job of explaining this first one, so I'm not going to go over that one. I'm going to skip and talk to you about maybe number 12. We have a moving car, and he's moving up a hill, and he comes to a complete stop. Um, and so we have two different moments in time. This is in the beginning, and this is in the end. Okay, so we want to determine. I feel like this one's too easy. Let's do number 11. So same as problem 8, which is the first one you did, but now we're stopping our snapshot for the second time before it gets to the top of the loop. Okay. So in the beginning, this car is compressed with a spring. It has no height. Remember, our questions are: does it have velocity? Does it have height? And does it have a spring? And when I'm compressed against this spring, I have no height and I have no velocity. So the only energy I have in the beginning is a spring. So I'm going to give myself 4 boxes of spring energy. Okay. And then at the end, do I have a spring anymore? No, because the spring is no longer in contact. Do I have height? Yes. But is it the maximum height? No, it still has height to go. So on this other example, where we may have put that it had 3/4 of its energy height and a quarter of it velocity, over here now, we're not quite as fast, not quite as high. So maybe we do this as half and half velocity and potential, or kinetic and potential, because we do in fact have velocity and we do have height, but we have half the amount for both that we did in the before. What's important is that if I have 4 boxes over here, I need to have 4 boxes over here, because what we're trying to demonstrate in our LOL diagrams is conservation of energy. And so when we have a closed system, which the ones that I've assigned you are closed systems, your energy has to be conserved. What you have over here has to equal what's on the other side. Now, down here on the bottom, it says qualitative conservation equation. In other words, it recognizes that you don't have numbers, but we do know that what happens before has to equal what happens after. So my spring energy equation is that 1/2 K uh, delta x squared. And then the equation for kinetic is the 1/2 mv squared plus potential energy is mgh. So they're not expecting you to solve this for anything. They're not expecting numbers to go in, but they do want you to, like, hey, this is the formula I would use if I had numbers for this scenario. Okay. So that's the expectation I have for 8 through 18 is I want you to complete the LOL diagram and list inside the zero the objects that are involved. Um, and then give me the conservation equation. If there are specific ones that you're needing help with, or if you need additional assistance with this, you can email me and say, hey, Miss Smith, I'm working on number 14 and this is what I've got. I'm not sure if it's right. And I will absolutely respond to you within the 24-hour time period. I hope this helps you. Reach out to me if you need assistance. And I'm going to do another video here in a minute, just as an overview of what my expectations for this week are, as far as like what I'm hoping you are learning. So hopefully these two videos will assist you. You guys have a great day.